So now what we want to do is we want to predict the last name, predict using the last name. Okay. So how do we do that? So we'll say fit. So now that we have this last name column, we'll say fit is GLM because we are predicting zeros and ones. So survived. And then using last of name and data is Titanic. So that's going to be our fit. So now what we can do is we can compare the accuracy to the baseline classifier. So first of all, what's the accuracy? So if we do predict fit, new data equals Titanic, and type equals response, what we'll get is the probabilities associated with each person surviving as predicted by fit. So we can get it true and false, like true survived, false did not survive, by going greater than 0.5. So the reason is that those are probabilities. So if the probability is greater than 50%, we want to predict survived. So that would correspond to true because it's greater than 0.5. If it's not greater than 0.5, we'll predict false. Okay, so that's like that. So now we can say, okay, so those are the predictions. And we want to know how often do those predictions match what actually happened. So we can say preds is equal to Titanic $survived. So that's ones and zeros. That's trues and falses, but trues convert to 1, falses convert to 0. So those would be trues when the prediction matches survived, in the sense of like 1 converts to true. So if it's like 1 and true, or if it's 0 and false. It would be false if the prediction is not the same as survived. So we have as many trues as we have correct predictions. And if we do mean, we'll get the proportion of the correct predictions, which turns out to be 92. So we also want to compare it to the baseline classifier. So the baseline classifier just either always says survived or always says died, whichever one makes more sense. So we know that more people died on the Titanic than survived. If we don't, we could check. And we'll just do mean of, so if we do mean of Titanic $survived, we'll see that that's less than 50%, so it makes more sense to predict died. So we can do mean of survived equals false. So if we predict died every time, then this guy would be true when we predicted died and we were correct, and it would be false if we were wrong. So the rate is 62, so a lot smaller. So now we are asked to compute kind of various other measures here. So let me do that. So I'll write the function FPR. That's going to be a function of fit and of Titanic. And this would be the false positive rate. So the number of times the model said positive was wrong divided by the number of actual negatives. Okay. So we'll get the predictions again. And here it's just a matter of computing things. So number of times the model said positive but was wrong, so that means preds is true but survived is 0. So we'll just say preds is true, and also Titanic $survived is 0. So here, by the way, so I'll be nice and put parentheses. So here, the reason preds does not have Titanic $in front of it is that preds is just a variable, but survived is a column of Titanic. So in order to access it, I need to say Titanic $. So now, in order to count up how many of those there are, I'll just do sum. So the reason this works is because this is trues and falses, and then this is also trues and falses, and the only way that this is true and this is true is if the prediction is true but survived is 0, which is what we want. That's false positive, right? Because we say true, so it's a positive, but it's not actually true, so it's a false positive. And then we want to divide by the number of negatives. So negatives are just actually false. So actually this is true when it's a negative and it's false otherwise. So we can just sum this thing up. And that is going to be our FPR. So if we do fit Titanic, we'll get our FPR, which is 5%. So similarly, we can do the FNR. So false negatives are kind of like the flip side of false positive. So it's the prediction is false, but they actually survived out of all the people who survived. So out of all the people who survived, about whom are we kind of having... So this is actually... so out of the people who survived, we want the false predictions. So we can do FNR fit Titanic, and we see that the false negative rate is 10%. So we also want to compute the PPV. So that's different because the numerator here is the model set, the denominator here is the model set positive. So we'll do PPV so we still need the preds. So what we want is the number of times the model set positive and was also correct. So I'll just copy this and then fix it up. So the model set positive and was also correct out of the number of times that the model set positive, so that's this. Okay, so one pattern that you notice here is that I'm saying this, and then I'm dividing by one of the terms here, sum of, right? And that actually makes sense. So what I'm saying is, out of all the times that survived was 0, how many times were the predictions true, right? So in order to count how many times were the predictions true, I need to say prediction true, and also that's actually inside the category that I'm interested in, which is survived equals 0. So that makes sure that the numerator here is always going to be smaller than the denominator.